Oh, now why is it?
Oh, I wrote down. What is it? I will not go to the party and eat some things good.
Okay, sorry. Alright, so we've got a particle moving in the xy plane so that anytime t, the position of the particle is given by these two parametrics. And it asks you to find the velocity vector, which means that you can find each component separately. So this is different from dy dx, which we did last lesson. This is just like the velocity vector. So you'll tell me the velocity in the x direction and the velocity in the y direction, and they're two separate components. So this is just dx dt, and this part is just dy dt. Okay? So dx dt is and dy dt is 4t cubed minus 3t squared. And then when you want to find it at t equals 1, then the velocity vector will be 8 plus 3 is 11, 4 minus 3 is 1. So the velocity vector when t equals 1 is 11, 1. So this is the movement in the x direction. This is the movement in the y direction. Acceleration vector is also just as simple. You just take the derivative of both. So this is d squared x over dt squared. And this is d squared y over dt squared. And since we're taking the derivative with respect to t, you don't have to divide by dx dt again, like you do when you're doing dy dx. Okay, so this is just 6t plus 8, right? And this one is 12t squared minus 6t. And if you want to find it at t equals 2, you just plug in 2, and you get 20 and 36. Yeah. Okay? Two separate components, super easy to find velocity vector and acceleration vector of these two, right? Okay. A particle moves in the xy plane so that at any time t, the position of the particle is these two components. Find the magnitude of the velocity vector. So if you remember from physics, magnitude of the velocity vector, that's magnitude, looks like this. I think it's only 1 bar in physics. That's what my 5th period told me. But, in calc we do 2 bars because the 1 bar looks just like an absolute value. The 2 bars look like magnitude. Whatever though. You do whatever notation you want to do. Anyways, what's magnitude of a vector? Anybody from physics? Yeah. Yes, that's actually, yeah, that's perfect. So it's the component squared, which is, since it's velocity, we'll be doing dx dt squared plus dy dt squared. And it will give you a number, right? For magnitude, magnitude gives you a number, which is basically the size of the velocity vector. So if magnitude of the velocity vector is equal to the size, then you can kind of think of this. Anytime it says magnitude of the velocity vector, this is the same thing as saying speed. Okay? So speed is the magnitude of the velocity vector. If you remember back in the day, when we were doing just one directional movement, it was in like unit 1 or 2. Do you remember this where we were like, oh, here's particle motion in one direction, right? And speed was absolute value of velocity, right? Well, you can kind of think of this in a vector form. Speed is still absolute value almost of velocity, but since you have two separate components, you've got to combine them and find the actual size of it. So speed is the same thing in one-directional movement as it is in two-directional movement. You just have to find it a little bit differently, okay? Because one-directional movement, you only have one value, but two-directional movement, you have to find the two combined. Okay, so let's find the magnitude. Magnitude of the velocity vector is square root of, and you have to do dx dt, which is 2t plus 3 squared plus dy dt. 3t squared minus 6t squared. Okay, you want to find it when t equals 1. So velocity vector at t equals 1 is square root of 5 squared plus negative 3 squared, which is square root of 34, right? Are you with me? Okay. Everybody's good? All right. A particle moves in the xy plane so that x equals root 3 minus 4 cosine t and y equals 1 minus 2 sine t from 0 to 2 pi. The path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled by the particle between the two x-intercepts. So how do I find the x-intercepts? Yeah, we're going to set y equal to 0. So x-intercepts mean that y equals 0. Because if y equals 0, then that's where it crosses the x-axis. So we said 0 equal to this y equation. 1/2 equals sine t. T equals pi over 6 and 5 pi over 6, right? Okay, now, this is how I think about distance. Remember, these are particles and they're moving over a plane. So remember in last class I told you that distance was what formula? Nobody remembers. Yes, arc length, right? So arc length is distance traveled. Distance traveled by the particle. So we're going to go pi over 6 to 5 pi over 6 of the square root of dx dt plus dy dt. And you don't have to simplify it because it says write an expression, but do not evaluate. You can also think distance traveled in, what's distance traveled in like non-parametric form? What? Oh, I get it. Okay. But no, like distance formula, if you're only given like one directional movement. Integral of integral of the absolute value of velocity, right? That's like distance formula for non-parametrics, right? Because we're taking, it's like, which is the same thing as the integral of this part right here is speed, right? And then don't forget that speed in this equation, speed in vector or parametric form is this equation. So when you're going to speed or distance traveled in parametric form, you use the speed equation in parametrics. So that's how I sometimes associate it. I'm like, oh, distance is integral of absolute value of velocity, but velocity in parametric form is magnitude, so I have to do this formula instead of just the absolute value of velocity. Am I confusing you? Okay, forget what I said then. So same thing, speed is the magnitude of velocity in parametric form. Okay. You can just remember to do arc length every time it says distance traveled for parametrics. Okie dokie. Let's do example 4. A particle moves in the xy plane so that at any time t, the position of the particle is given by these two parametrics where t is greater than or equal to 0. For what values of t is the particle at rest? How do you know if a particle is at rest? Yeah, velocity equals 0, right? But this time we've got two directions that are moving. So if we want the particle to be at rest means that both dx dt has to equal 0 and dy dt has to equal 0. If they both don't equal 0, then it means something's moving. Yeah, if if dx dt does not equal 0, then it's moving in the x direction. And if dy dt does not equal 0, then it's moving in the y direction. Okay, so I want you to find dx dt and dy dt, set them equal to 0, and solve for your t values. Did you finish? Did you get t equals 2? No? Yeah, they both have to equal 0. Okay. Here's the answer from that one. What? No, it's somebody else's. Okay, here's the actual particle. So if you want to see it, there's you don't need it for the AP exam, so don't worry about if you don't know how to go to parametric mode. But there is a parametric mode on your calculator, and if you type in the two x component and y component, this little thing, you can switch to ball and chain, and then you can see the path of the particle moving. And if you graph it, you can actually see that the particle moves like this. That hesitation, that's where t equals 2. So do you see how it stopped moving right there? Or do you want me to do it again? Okay. So watch it again. That's at t equals 2, and then it stopped moving, and then it kept going on.
Set the window at the stopping t equals 2.
Well, I don't want to stop it at 2 because I want it to go on. I want you to see. Let's go 3. Sure. This is very slow-mo. There you go. Maybe this is a little too slow too. Yeah, that's the stop. And then it keeps going. Okay? Do you see it? All right. Another example. A particle moves in the xy plane in such a way that its velocity vector is this if its position, just say if its position is 7, -4. Find the position of the particle at t equals 1. So at t equals 0, you're at 7, -4. Find the position of the particle at t equals 1. How do I go back from velocity to position?
Integrate.
Good. So it's just the integral of this, which is
T cubed minus 2t squared.
and then we have a plus c, right? And then the integral of this is two t to the 4th. Am I doing that right? Plus 5t plus c. Then at 0, this should equal
7.
and -4, right? So what does C have to equal for this one? I'll name them C1 and C2 maybe. C1 has to equal 7, and C2 has to equal -4, right? So I can go back and make my vector t cubed minus 2t squared plus 7 and 2t to the 4th plus 5t minus 4. And then we can plug in 1 and get six and 3. Yeah? Okay, so the position of the particle at t equals 1 is 6, 3. All right, calculator examples, because you'll need your calculator for a lot of these questions. All right, this one is simple. Write the equation of the tangent line to the curve at the plane where t equals 2. How do I do tangent lines? dy dx, I need the derivative. I need this change in y over the change in x. So I already have dy dt, so that's just cosine of t squared, divided by dx dt. So let's just do it at t equals 2. Oops. Cosine of x squared over sine of x cubed. 1.064. Yeah. Yes. That's all. Oh, sorry.
Yeah.
Only Jun-sung noticed that. I'm disappointed in you guys. Thanks, Jun-sung. Okay, 0.661. Negative. All right. Now what else? Tangent line. Do I have the x and the y? I do. At time t equals 2, the position is 7, 4. So I don't even need to find it. Y minus 7? Nope. 4? Equals negative 0.661 x minus 7. Any questions on number 1? Number 2, speed is the what? Speed in parametric form. No, not yet. That's distance. Speed is just magnitude. So we do square root of dx dt squared plus dy dt squared. And then we plug in at t equals 2. So maybe I should plug in at t equals 2. Yeah. What? Remove what thing? Oh, if you press second INS, then you can insert something in between. Then you don't have to rewrite it. Why are you retyping everything?
How many times did I mess up the calculator portion because
This is like the biggest revelation of BC calculus ever. No, you just press second, and then this means insert. Have you never used a computer before? No, so I can type in as many numbers as I want in front. No, you just press second INS. Are you with me, Zach? Why is the overwrite the default? That's the question. I don't know. Do you just clear it every time? Or like type over it every time?
Yo, how many points did I lost because of this?
No wonder these tests are like so time consuming for you because you're rewriting it. Okay, so you have no excuse. I'm just joking. Okay. All right, now that you know.
I need some water.
All right, guys. I kind of am glad that I recorded this so I can go back and listen to this crazy revelation of yours. Yeah, I guess I should. I just assumed that you guys knew. I think so. They do have that AP Bio movie. Have you seen that? Oh, what? Oh, no, they have an AP Bio show. Yeah, it's called AP Bio. I watched the first episode and I was like, this is very unrealistic. Okay. Guys, we have to finish. Does the tangent line, for what values of t in between 0 and 1 does the tangent line to the curve have a slope of 4? Okay. So I want dy dx, that's the tangent line slope, to equal 4. And I already know from up here that dy dx was this. So I'm just going to set this equal to that. Alright, how do I solve this? Yeah, you have to use your calculator. So 4 and 1 doesn't matter, and then cosine of x squared over sine of x cubed. And then window 0 to 1. All right. So we do second calc intersect. What's wrong now?
I learned about the fraction thing.
Just now?
Yeah. Alpha y1. Oh, no.
Alpha y equals.
2 months ago.
It's easier to do that than a million parentheses.
Yeah, I'm just gonna have all the
I didn't even know that these were actually multiple.
Yeah.
And I learned this.
Yeah, the first one gets you fraction. These do, if you do alpha y2, you can get the derivative and the integral. But I just do math 8 and math 9 is easier than that. Anyways, okay, so I found the value of t where the curve has a slope of 4. Now what do I do in order to find the acceleration vector? Yeah, I have to do the second, this is already the first derivative, so I have to find the second derivative of both of these at t equals 0.616. I can do that by hand, but since I already have the calculator, let's just go math derivative, math 8, and then I'll just do the dx dt first, so sine of x cubed. And then x, when I calculated the intersect, is already stored in, so I'm just going to do x equals x. So 0.616, is going to go into the derivative of this. And so you are 1.109. So that's the x. And then I need to do the derivative again. So math 8 cosine x squared, x equals x, and that's negative 0.457. And so those are the most exact that you can get them from the calculator values. All right. Okay, almost done. Find the position of the particle at time t equals 1. So right here, we have dx dt and dy dt, and we kind of want to do it the same way that we did this one, where we integrate it and add the plus c, and then plug in our value to find the plus c and get then the position vector. But there's a problem with this one, in that I can't integrate this unless there was what on the outside? T squared, yeah. And I can't integrate this one unless there's a t on the outside. So you have to use your calculator to do it, because you have a position that you know. At t equals 2, the object is at 7, 4. And you can use your calculator on a bounded integral, but not an unbounded one. So if I want to find the particle's position at time t equals 1, then x of 1 will equal, what's my position at 2? 7, right? So I start with my position at 2, and then what do? Subtract the integral from 1 to 2, the change in my position from 1 to 2, because you can do bounded integrals. Yeah, it's reverse, it's, I don't know what it is. It's just math. So you can do the same thing with y. You know your y position at 2 is 4, and then you can take away the change from 1 to 2. And you can integrate with bounds on your calculator. Everybody knows how to integrate with bounds, right? I don't trust you anymore. Okay, so that's our x. And our y is 4.443. So this is the only way you can do this problem, since you can't integrate these by hand. You have to use your calculator with bounds on them. Oh, thanks. Negative 4.443? Is it negative 4? Oh, it's negative 4 for example 5, but it's positive 4 for example 6. Yeah, I should have used different values so that it wouldn't be easy to mix up when I made this, but too late. Okay? Do you get it? All right. Now that you've learned something today, it's time to practice.